Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the pin description of the programmable interrupt controller whose IC number is 8259 and it is also known as the PIC. So let's start with the topic. The programmable interrupt controller, it is designed to handle the interrupt operation, the multiple interrupt operations of the microprocessor systems like 8085, 8086 or 8088. Okay. Now the IC for this programmable interrupt controller, it is 8259. We have 8259A also, which is the updated, or we can say the higher version of 8259. The difference between the two ICs is that the 8259, it can be used with the microprocessors like 8086 and 8088. Whereas the 8259 IC, it is used only with 8080 and 8085. So as the microprocessor version is increasing, the updated version or higher version of this 8259, it can be used. Now let's come to the pin description. This programmable interrupt controller PIC, it has 28 pins. And each of the pins will be assigned a function, and let's see that what are the functions associated with these 28 pins. And this IC this 8259, it works at a plus 5 volts power supply. It is needed to use this IC. Now let's come to the pin diagram. So this 8259 IC, it is having 28 pins. You can see this is the pin diagram for this, having 28 pins, 1 to 14 on one side and 15 to 28 on the other side. This is the pin diagram for the higher version, that is 8259A. Okay. Now in this pin diagram, you can see that on pin number 1 we have the CS bar signal, on pin number 2 we have the write signal, on pin number 3 we have the read signal. This is CS means chip select, WR means write, RD means read, okay, and these signals are having a bar over it. So these are the active low signals, means they will be active when their value is 0. That is why a bubble is shown here. Okay, whenever a bubble is shown means that the signal is active when its value is 0. Okay, then we have the bidirectional arrows. These are showing that this is the data bus, the 8-bit bidirectional data bus starting from D0 to D7. So this is the bidirectional data bus. That is why the arrows are in both the directions from pin number 4 to pin number 11. Okay. Now pin number 12, 13 and pin number 15. These three pins are the cascade lines CAS 0, 1 and 2. So there are three cascade lines. Okay. Then we have ground and VCC, which are the power supply connections. As I have said that this IC, it works at a plus 5 volts power supply. So plus 5 volt will be connected here and ground will be connected here. Okay, at the 14th pin. Now pin number 15 we have already discussed, it is the cascade line number 2. Okay, then 16 is again a bidirectional signal, which is slave program or enable signal. These are two active low signals, so it is also having bar over it. Then we have INT and INTA bar. Okay, so INTA bar, it is an interrupt acknowledge signal which is provided by the microprocessor to the 8259 IC. So that is why it is an inward coming signal. If it is outgoing means that this signal is provided by the 8259 IC. Okay, so this arrow, it is coming out of this means this INT, that is the interrupt signal, it is provided by the 8259 to the processor. Okay, then we have the interrupt request. As this 8259, it is able to handle 8 interrupt requests at a time. So these are the 8 interrupt requests, IR0 to IR7. These are the interrupt request signals, means 8 interrupt requests can be sent to the 8259 at a same time. Now we have interrupt acknowledged. I have already said that this is the acknowledgement signal coming from the microprocessor to the 8259. Whenever 8259 it is going to send a request to the microprocessor will send this signal interrupt acknowledged to tell that it has received the request and it has executed the service routine also. Okay, then we have A0. This is the address line of the microprocessor, and this address line will decide that the data which is available on the data bus, it is either the control word or it is also used to select this chip also in 8259 is also selected. So it decides that the modes of the 8259 by this A0 signal. Okay, VCC we have already discussed, it is the power supply connection. So these are the 28 pins of this 8259 IC. Now let us study these pins one by one so that in detail we can study that what is the function of these signals and what these pins describe. Okay, so first we will start with the CS bar, that is the chip select signal. As the name says that this signal, it is used to select the chip. Chip is the 8259 chip. Okay, so whenever the microprocessor it want to use this 8259 programmable interrupt controller, it has to select that chip. Okay, so this signal CS bar, it is used to select the 8259 IC, and when this chip is selected, then only the read or the write communication or the communication between the microprocessor and the chip is going to start. Okay, so it is necessary to select the chip. How it can be selected? Because this signal, it is an active low signal, so it will be active when its value is 0. So this 0 has to be provided on this chip signal. so that the IC 8259 is selected, and then the communication will take place between the microprocessor and the 8259. So to access the 8259 chip, the CS bar signal, it is made low, and this signal, when it is low, when it is active, it enables the read and the write communication between the CPU and the 8259. Now how this signal is made low, how this signal is provided to the 8259? Whenever because when we want to select the chip, suppose this is the microprocessor, this is 8085 or 86, and this is 8259. So when this 8085 it want to select this chip, it has to provide the address. Okay, now this address, it is decoded, it is provided by 8085, and that address is decoded by a decoding logic circuit. So this decoder logic circuit, it is going to decode this address, and then it is going to provide this CS bar signal. It is going to active this signal so that 8259 can communicate with the 8085 or 8086. So this signal CS bar this signal is made low by decoding the address assigned to this chip, and this decoding of address is done by the decoder logic circuit. We have a circuit specially designed using the logic gates also here. So using the logic gates, the circuit is designed, and this circuit is going to active this CS bar signal. Okay. Now whatever functions this 8085, 8086 does for the interrupt operations, those functions are independent of this chip select signal. Suppose this 8259, it is giving the interrupt request to the 8085, and this 8085, it is going to execute the service routine. Okay, and then it is going to send signals also, it is going to set like INTA acknowledgement signals also for end of execution of this service routine also. So all the functions which are performed by the microprocessor, they are independent of this CS bar signal. Okay, they are not interfered by this CS chip select signal. So this was the first, this is available at pin number 1 of the 8259 IC. Next we have the write and the read signal. WR bar, it is the write signal. Now this signal, it is also an active low signal, it is having a bar over it. So we can say that it's an active low. It will be active when its value is 0. Now when this chip select signal, it is low, it is enabling the read and write communication between the 8259 and the CPU. So when along with the CS bar signal which is low, if write is also low, then the data which is available on the data bus, that data will be written into the registers of the 8259 IC. Okay, so whenever the written operation has to be performed by the microprocessor, then this signal is made low. So whenever the CS bar signal is low and the write signal is low, it enables the 8259 to accept the command words from CPU. If we want, because this 8259, it has various types of modes of operation. In various modes it can operate. So those modes, that which mode is to be selected, that is decided by the command words. Okay, so these command words, they are written by the CPU into the control registers or into the registers of 8259. So whenever this write signal is low, then the data which is available on the data bus, which is the command word, and that command word is written in the control registers of the 8259. Okay, so that the 8259 can be programmed to work in the various modes of its operation. Okay, next we have the read signal, which is RD bar. This is the read signal. This signal is also an active low signal, so it will be active when its value is 0. Now again, when this chip select signal is 0 and also this read signal is 0. Okay, so read is activated. So the microprocessor, it is going to read the status of the interrupts from the 8259 IC. Okay, it is going to read the IC. So if this pin is low, along with the CS bar signal, it is also low. So when both these are low, it is going to enable the 8259 to release the status of the interrupts. Status of the interrupts means which of the interrupts are pending, which are serviced by the microprocessor, and which are masked. Okay, so masked interrupts, pending interrupts, in service interrupts, all this information about the status of the interrupts will be read by the microprocessor from this 8259 IC. So the 8259, it releases the status of the interrupts when this read signal is low. So status of interrupts, we can say masking interrupts, pending interrupts, and in service interrupts. So in the status of interrupts, all this information will be read by the microprocessor. Next we have the data bus. In the pin diagram, we have studied that this data bus, it is the bidirectional data bus, and it is used to transfer the data between the 8279 and the microprocessor. So this D7 to D0, it is the bidirectional data bus, and the control status and the interrupt vector information, it is transferred via the data bus. Control information means all the control signals, whatever be the control signals, the interrupt request signals, and the status of the interrupts, that which of the interrupts are masked and pending interrupts. And interrupt vector information means information about the addresses of the service routines. All those informations will be transferred via the data bus. The command words also, they are also transferred through this data bus. So if there is any data, any control status or the interrupt vector information, that will be transferred via the data bus. Now this data bus of the 8259, it is connected with the bidirectional data bus of the 8085 microprocessors. So when this 8085 and 8259 they are communicating, the data will be provided on this data bus, and this data bus will transfer the data on the data bus of microprocessor. Okay, so in this way the communication or the transfer of data takes place between the two. Next, in the pin diagram, we have the CAS 0 to CAS 2. You can see here in the pin diagram, we have the CAS 0, CAS 1 and CAS 2. These are the cascade lines. 3 cascade lines are there. Data bus we have already studied, and read, write and chip select signal we have already studied here. Now come to the cascade lines. Now, a single chip of 8259 IC, it can handle 8 interrupt lines. If we want to handle more than 8 interrupt pins, then we can use many number of 8259 ICs, and these ICs are connected in the master slave configuration. So one IC will be the master, one will be the slave. So in this way we can handle number of multiple interrupts. Okay, as we have studied in the features of 8259, that if we connect 9 8259 ICs, then we can handle 64 interrupt pins. Okay, so this mode of operation or this working of 8259, where we are using several number of these ICs, so that is known as the master slave configuration, in which one IC is acting as a master and others are acting as a slave ICs. Okay, so these lines, these cascade lines, because the ICs will be connected in a series with each other, they are cascaded, so that is why they are known as the cascade lines. And these lines, they form a local bus to control the multiple 8259 in the master slave configuration. In this configuration, if we want to transfer any data or any status or control information, then these 3 lines they act as a local bus, which is distributing or which is transferring the data to these ICs. Okay, so they are used whenever the 8259 it is working in the cascade mode or in the master slave configuration to transfer the data between the ICs. Okay. Now, to identify a particular slave, because when we are connecting 98259 IC, then one will be the master and other will be the slave. So to identify any of the slaves out of the 8 slaves, then these lines are also used to access or to identify the slaves and to access the transfer of the vector information. Okay, that is the address where the service routine is written. So all the addresses, if we want to access the address, if we want to identify a particular slave, then these lines are used. Okay, now these lines, they automatically become the input and the output lines for the master and the slave ICs. Okay, so for if we are having a master 8259, then these lines are set as the output pins, and if we are having a slave 8259, then these pins are set as the input pins. So accordingly their function is changed. When we are using multiple 8259, then for master 8259 IC, these lines will act as the output pins, whereas for the slave 8259 IC, these pins are going to act as the input pins. Okay. Next, in the pin diagram, we have studied these cascade lines. Then we have the signal SP bar and EN, which is the slave program and enable buffer. So let's study these pins, SP bar and EN bar. SP is for slave program and EN is for enable buffer. Okay. You can see that this pin, it is a dual function pin. It is doing the dual functions. It is used for slave program also, and it is used to enable the buffer also. So when this pin, when the 8259, it is working in the buffered mode, then this pin, it is used to as an output pin, and when it is not in buffered mode, then this pin is used as an input pin. Okay. So when it is not in the input, when it is not used in the, when this 8259, it is not in the buffered mode, then it is used as an input pin. So this slave program pin will be active. Okay, so in buffered mode it was acting as an output pin, and in not in buffered mode, then it is acting as input pin. So when it is not in the buffered mode or acting as an input pin, if this pin it is 1, then the 8259, it will act as the master IC, and if it is 0, then the IC, it is going to work as the slave IC. So this pin, it is deciding that whether the IC 8259, it is configured in the master mode or in the slave mode, whether it will act as the master IC or it will act as the slave IC. Okay, and when this pin, it is used in the buffered mode, so it is used to enable the data bus buffer, so that the communication between the microprocessor and 8259 can take place. So this was when the pins, or when the 8259, it is not in the buffered mode. Now when the 8259, it is working in the buffered mode, so this pin is used as the output pin. Okay, so output means that this function enable buffer, it is going to work. The data bus of the 8259, it is having data bus buffers, and whenever the transfer of data takes place through the data bus, then it is required that the 8259, it enable or disable these buffers. Okay, when these buffers are enabled, then only data transfer will take place. If they are disabled, then no transfer of data will takes place. So whenever the 8259, it want to transfer the data, it is going to enable the data bus buffers using this line enable buffer. Okay, so if it is 1 or it is 0, means here it is active low. So when its value is 0, then the buffers will be active, they will be enabled, and if its value is 1, then the buffers will be enabled. So we can say that in buffered mode, data bus buffers are used. Okay, So whenever the 8259 it want to transfer the data to the CPU, these buffers are enabled or disabled by making this pin SP and enable pin as low or high. So this pin, it is performing the dual functions. First is this pin is deciding that whether the in the non-buffered mode of 8259, it is deciding that whether the 8259 IC, it is acting as the master IC or the slave IC. Whereas in the non-buffered mode, this pin, it is used to enable or disable the data bus buffer so that the transfer of data can takes place between the CPU and the 8259. Okay, so these are the two functions of this pin. Now next we have in the pin diagram, this pin we have studied. Then we have the INT pin, which is the interrupt pin. Okay, so let's study about this pin. Now whenever the this 8259, its function is to whenever the interrupt request is being sent by the input output devices to the microprocessor, then these interrupt requests, according to their priority, they will be asserted by the 8259, and in response to it, the 8259, it is going to interrupt the microprocessor. So whenever any valid interrupt request is given to the 8259, then this signal interrupt output is made high so that the CPU can be interrupted. Okay. So this pin, it goes high whenever a valid interrupt request is asserted, means whenever an input output device it is giving an interrupt request to 8259. So in response to that request, the 8259, it is going to produce this, it is going to make this pin high, and this pin, this interrupt request, this interrupt output, it is connected to the INTR pin of the CPU. Okay, the microprocessor, it has the pin interrupt request. So whenever an interrupt request is given to 8259, 8259 is going to give this INT signal to INT R pin of the CPU. So if we take it, this is the 8085, it will have the pin INTR. This 8259, it is going to send the signal INT whenever it has the signal interrupt request. Okay, so whenever an interrupt request is given to 8259, 8259 will give INT to the INTR pin of the 8085. So in this way, the 8259, it is interrupting the CPU. Okay, it wants that the CPU stops its operation, and first it is going to execute the service routine related to this interrupt request. Okay. Now when the 8259, it is working in the master slave configuration. So in this configuration, the interrupt pin of the slave IC, means slave 8259, it is connected to the interrupt request signal. Okay. So when this master slave configuration, So when the ICs they are working in the master slave configuration, then this pin, interrupt output pin of the slave 8259, it is connected to the interrupt request pin, that is this IR pin of the master 8259. Okay, so it means that the slave 8259, it is giving a request to the master IC that I want that this interrupt should be executed first. Okay, so if this is the master and it is the slave, so this INT will be connected to this IR interrupt request line of the master. Okay, so here in the pin diagram, if you see, we have the INT, it is the output signal, so it is known as the interrupt output. Okay, and if this is the slave IC, then this interrupt output will be connected to the interrupt request signals of the master IC. Okay, that was what I am saying. Then next signal we have in the pin diagram, it is the INTA bar, which is the interrupt acknowledge. Okay, this signal, it is at the 26th pin. Now this signal, it is coming towards 8259. So this signal is generated by the microprocessor. Okay, and this signal, it is an acknowledgement signal which is associated with the interrupt request. So this is an acknowledgement signal for the interrupt request, and whenever the 8259, it is going to interrupt the CPU, then in response to that interrupt, the CPU, it is going to generate this signal that it has accepted the request, and now it is going to execute the service routine related to that interrupt. So this INTA interrupt acknowledge signal, it is used to enable the 8259 interrupt vector data to be available on the data bus by a sequence of interrupt acknowledge pulses issued by the CPU. So if this is the CPU and it is the 8259 IC, so this CPU 8259, it will get an interrupt request, and in response to this interrupt request, it is going to give the signal INT to the CPU. Now INT, this signal, it is given at the INTR line of the CPU, that is interrupt request line. Now when this request is given to the CPU, then CPU will generate the signal INTA bar. Okay, this signal shows that the CPU has received the request and it wants that 8259, it should provide the address where the service routine is written, so that the microprocessor can go to that memory location and can execute the service routine. So the address is available to the 8259. So when this signal is given to 8259, it is going to transfer the data or provide the address on the data bus. Okay, so I have written here that this signal, it is used to enable 8259 interrupt vector data, that is the data which is available with the interrupts, the vector address on the data bus by a sequence of interrupt acknowledge pulses issued by the CPU. Okay, so in response to these interrupt acknowledge signals, the address, the interrupt vector address will be available on the data bus. Okay, so that is the function of this interrupt acknowledge signal. Next come the interrupt request. As the 8259, it can handle 8 interrupt pins, so there are 8 interrupt requests. Okay, so we have the IR0 to IR7, which are the interrupt request input. If you see in the pin diagram that these lines IR0 to IR7, they are the input lines. Okay, so these requests are given by the input output devices to the 8259 that they want to communicate with the 8085 microprocessor, or they want to interrupt the microprocessor. Okay. So these are asynchronous interrupt request pins. So whenever the input output devices they want to send an interrupt request to the 8085, then first they will interact with 8259. They are going to give the interrupt request to the 8259 programmable interrupt controller, and these pins are IR0 to IR7. So these pins can be made either we can raise the level of these input lines. If it is low, we can raise its level to high, means from 0 to 1. If we change the level, then also these interrupt requests can be given to the 8259, and also we can just change by a high level also, means like if we want the edge, because there are two types of interrupts, level triggered and edge triggered. Okay, so if we are giving the level triggered interrupt, then we will change the level of the interrupt request pins. We can make it from low to high, from 0 to 1, and if the interrupt requests they are edge triggered, then we can have the edge of the high level. Okay, so both the types can be done, both types of interrupt requests can be generated depending upon whether they are level triggered or edge triggered. Okay, so these interrupt request signals, they are an input signals to the 8259. We have here the 8259, so it can handle 8 interrupts. So there we have the 8 interrupt request lines from IR0 to IR7. Okay, and depending upon whether they are level triggered or edge triggered interrupt request, we can change the level either from low to high or by a high level also. Okay, next we have the address line A0. This address line, along with the read, write and the chip select line, it decides that the data which is available on the data bus, whether it is to be written or it is to be read by the 8259 and the CPU, and the data it is to be written, means the command words they are given through this address line. Okay, so along with the read, write and chip select pins, it is used to send the command words. So along with this read, write and chip select signal and the value of this A0 signal, these signals they are used to send the command words from CPU to 8259. Suppose this CS bar signal it is 0, read signal is 0, write signal is 1. So read is active, so its function is to read the status of the interrupt service registers, and all the information about the interrupts will be read by the microprocessor. So then the status of the interrupts will be read. If suppose the write signal is 0 and read is 1, then the data which is on the data bus that will be written into the control registers, means the data is the command word. So it is also used to send the command words from CPU to 8259. Now when the this A0 address line it is connected to the address line of the CPU of the microprocessor. Okay, so microprocessor like 8085 it has 16 address lines from A0 to A15. So the A0 address line of the 8085 will be connected to the A0 address line of the 8259. Okay, now when this A0 is 0, then the address is known as the even address. If it is 1, then it is known as the odd address. Okay, so these two addresses are used or this A0 line it is used to decide the various command words. When we will study the modes of operation of 8259, then we will see the use of this address line A0. Okay, so these are the various pins or the 28 pins of the 8259 IC. We have seen from 1 to 28, starting from the chip select signal, read, write, the bidirectional data bus, then the power supply connections, VCC and ground, then the cascade lines and the slave program enable lines also we studied, then the interrupt output and the interrupt acknowledge signals we have also studied. So all the 28 pins we have studied the descriptions of all the 28 pins in this video. Okay, so I hope that this topic is clear to you. Thank you.